about myself. I said before that I was doing security since the beginning of time. Feels right like this. I've been doing computers almost as long. No one starts out to be a security expert. We start out to solve problems, to design infrastructure, to build things. Yeah, I got the video. What we actually do is we should be looking at solving problems. Just screen. We should be looking at solving problems, not trying to defend the world, but let's build a world. Unfortunately, we find ourselves trying to solve problems. One second, cannot type and work on computer.
We have it on Teams account.
That's good. Let's hope everything is today. Don't bother. If he has logs. No, you're good. Right, so I'm doing it right now if you've got that turned on. Can you all see me yet? Okay. So a little bit of background about me. For those of you who recognize the name, it's Michelangelo. No relationship to the painter, didn't write the virus. That would be a felony and illegal in multiple countries. And I have no idea where the rest of the turtles are. This having been said, is there anything on the screens yet?
Yes.
Yes? No? You all still awake?
Yeah.
Okay. So with this having been said, a little bit about myself. I've been doing security since the beginning of time, and I'm not usually used to presenting, so please bear with me. I guess because I've been doing it so long, I've got a few patents as well. I've got 77 worldwide, which is kind of interesting. I didn't try to do it, I just actually happened to do it in the process of trying to solve problems. And one of these days I will learn how to use PowerPoint. Is this not working? So let's talk about software and what's in your software. This is something that I think is fundamental to a lot of the problems that we have. Let me actually back up 1 second. I saw before, how many of you are students? Okay, look to learn how to solve problems. How many of you are hackers? Hey guys, I really appreciate it. You've kept me in business, made me an awful lot of money over the years. Keep up the good work, and hopefully, you'll eventually realize that there's a lot more fun in solving problems rather than creating problems for people. With that in mind, today I'm going to talk to you about the problem with software and what's in the software, which is really the back end issue. I'll talk about why it's a problem. I'll give you some ideas on some mitigations, and as I've been doing work and research, I have some ideas on how we can solve the problem, and I will push it from there. So the problem. What do home laser printers, cars, medical devices, and centrifuges have in common? Anyone? Just spell out an answer. What? Software? Did I hear software yet? Power. No, it's not the power. Although they do have power, yeah. The problem is that they're all computer controlled, and when they're computer controlled, they have software. And when we are dependent on software, we can guarantee 100% that it was not engineered to be secure. We can guarantee that it was engineered to do a function, whether it's a pacemaker that has remote control or remote access to monitor a person, an insulin pump, a car, whatever. We know it wasn't done to be secure, we know it was done to provide a real function. And yes, it can be hacked to create unintended consequences. I mean, there's probably nothing more fun than dumping someone's insulin into their blood remotely while they're walking down the street, or watching a pacemaker trip as an automatic defib. Yeah, good stuff. Sorry, I'm a little bit cynical at times. So why is it a problem? Well, software uses components. open source components, which everyone contributes and are really good because people get together and they solve a problem. Commercial products, which they buy to put into the software anyway, or they use to put in the software to solve the problem into graphics. How many people want to write a program to analyze a bitmap and display a bitmap? Well, it's not really the part of what most people's program is, so go out and buy the software. And homegrown components. So for those of you in industry, you'll have your teams write a program which solves a problem, and they'll use open source components and they'll use commercial products. In short, they use pieces from everywhere. So when we look at it, the components in themselves may also use components. And they may use other components and other components and other components. So when we think about this, we wonder, how bad can things actually get? Well, these components have vulnerabilities in them, and they're non-traceable vulnerabilities. Has anyone ever heard of the OpenSSL bugs for the past 6 months? Anyone? Yeah, right? Yeah, right. And what happened? Everyone sat there and said, oh my gosh, I use OpenSSL quickly. Let me figure out if I've got that vulnerability. Okay, the heart, and I still can't even say the word right, the heartbleed bug or whatever, that vulnerability has been known for 3 years. And the technology behind that vulnerability has been known for 30 years. Yet we still do it. Why? Because, well, we wanted to check and see if the SSL sessions were up, so here, let's implement a ping. We don't think about it. The bash bug, as I like to refer to it. How many products use bash in their infrastructure? Okay? So, why is it a problem? When we start taking these homegrown solutions or the open source that have open source and open third-party components, we don't know whether or not they've got vulnerabilities. And commercial products have the same thing. If you buy a product from me, you don't know if I've done my job, because all you know is that the product works for the function and feature that you've looked for, but you don't know about the components. So when we talk about it, software has issues, not necessarily because the software itself wasn't done properly, but because it was incorporating components, those pieces of code that everyone uses that are ubiquitous. We can try and train people and say, here's how you write software properly, right? We can tell them, pay attention to the warnings in the code. When you compile a product or a program, the reason it's got a warning is because you're not doing something right. How many of you are programmers? Okay, how many of you have never gotten a warning when you compile a product or a code? How many of you have gone back and closed all those warnings up? Okay, problem is we ignore them. Why? Because the job is to get the code working to solve the problem, not to fix it, not to make it secure. It's just to get it working. And that warning integer pointer mismatch, well, that's nothing. And uninitialized variable, that'll never cause a problem for me. So it doesn't really help training. Best practices, we can look at the common weaknesses in enumerations, the common vulnerability enumeration database. It's good for products you know about. But if you don't know that there's a component in your product, then how are you going to look at it? Think about Java. I love Java. When Java first came out, I looked at it for about 20 minutes and said, this isn't secure. And what are we up to, 7.178 versions of Java? And I was like, okay, still not there. But everyone uses it, and it's still not secure. Third-party libraries, graphics libraries, all that sort of stuff. How do we see those? Well, if we don't know they exist, we can't possibly go and correct the issue. So that really doesn't help looking at best practices. We can look at automated analysis. Nessus, Metasploit. These are really good tools. They'll tell us if there may be a problem in our product or our infrastructure. And Metasploit will actually tell us, hey, this has been weaponized. Real good stuff. Downside is too many false positives, or worse, what if it doesn't find it because it's embedded in a third-party component? So it doesn't know that you're running JBoss 4.7 or DevExpress 1019. Okay, but I just ran this tool and it should have told me there was a vulnerability in my system, but it doesn't necessarily find it. So that doesn't really help. A second set of eyes, certifications. I love certifications. How many of you have products that are C2 secure? Does anyone remember what C2 secure is? Well, the reality is you can't because that's been obsoleted, but I saw it recently on a request for procurement, an RFP, an RFI, and they said that the product needed to be C2 secure. Well, in 2001, we made that obsolete. Common criteria. Okay, common criteria is great. It says, tell me what you did for security, or I'll tell you what I want you to do for security, and then we prove it. I've actually done about 12 of these right now, and I used to have hair when I started, and I've been pulling it out regularly because of it. Standards, FIPS 140, FIPS 180, FIPS 197, mumble. All these are good if you comply to them, but they don't talk about the implementation of the usage of that particular technology. So I use AES, great. It's FIPS 140 validated. Yes, this is fantastic. And when I implement it in my product, I store the password in a file on the disk so that we have cache consistency. Oops, not a good thing, but I'll delete the file so no one will ever find it. These certifications cost lots of money, but you still have the problem because they don't necessarily look at the components. So that doesn't really help. Testing. You know, we can always run testing. Anytime you get new software, you test it in your environment. We look for, does the program work? Does it have any known vulnerabilities at that time? You still might not get there. You may not discover them. And by the way, how many of you go back and run security vulnerability tests against software that you bought 6 months ago? No, you're too busy paying attention to the new software. You may run a scan on your system in general, but you know, not many people do that, and even then you might not know the component is vulnerable. So what can we do about this? To succeed, to protect our infrastructure, we really need to know what's in the software. You know, in the States we have an ad, what's in your wallet? They're asking about a credit card. I always go up to people and say, what's in your software? So what does it mean? What if we could look at these weaknesses and vulnerabilities and we had a product component list that identified, that we could actually go back and we could look at the CWEs and CVEs and say, oh, this product has these 4 components in it. And therefore we could go and say, oh, wait a minute, this vulnerability is in that version of that component. Let's go and look and make sure it's okay. Let's make sure that the threat is not realizable. Just because something has a vulnerability doesn't mean it can be exploited yet. So you can ask the vendor who, you know, or what they've got, and the vendor might not actually know what that module does or what additional modules are in there because they call someone else's product, which calls someone else's project, which calls someone else's. They might not be accurate. You know, in my case, we always identify all the third-party components, and then I go back and say, what about this, what about this, what about that? And they go, oh yeah, we forgot about that. Do we still use that? Yes, we do. Or you can do your own analysis. So if you can do your own analysis, you probably want to look at the components before installation. You know, but in order to do that, you need to extract the components without doing the install. And here's your standard MSI for Microsoft, you know, Windows, how you would go and execute a command to extract the components without doing the install. And then you can also do it with zip, and it's fairly easy. It still doesn't identify the components yet. It tells you what components are there, but it doesn't identify them. So you can identify the components by saying, look at the digital signatures, because everything's digitally signed, right? Yeah, right. Most of these components aren't digitally signed, so you can look at the hashes. Except for hash collisions, that's probably a good idea. And then finding a whitelist that actually includes components and not just products, that's probably not going to be found. So you're going to have to do multiple things. Look at the copyright in the file, look at the trademarks, the version information. Inside of a product, there may be a list of products which may be accurate. Okay, sorry. You can look at the third-party manifest. A lot of products have these. Sometimes it exists, and you you still are dependent on whether or not it's got all of the elements. The name, the origin, what's the name of the module, what's the version, the basic stuff that's embedded into the CVE. And if you got that, then you can look up the common vulnerability or the common weakness. But the reality is not all of these products, all these components, identify these things. So you're going to have to hunt, you're going to have to pick, you're going to have to play a little bit. So in theory, we can extract the information because we can extract the elements from the installer, and we can gather the component information and go forward. So, MSI expansion, this is kind of what you would do. Create a program which creates the command string, don't bother rewriting the extraction utility is there, it works. And then if you're successful, walk through the tree, grabbing all the strings. For those people who like code, here's how you would do it. Doing it being the expansion. I'm intentionally doing this to torture people who are C programmers or C# programmers. And then you would actually walk the tree. Fairly simplistic, done in a handful of lines, and I know that these slides are going to be posted, so don't bother writing really fast. And by the way, this is the code for the geeks. Expansion may not provide enough information to identify the components, so you are going to have to still analyze it. You may want to look at strings. I find using the strings command is usually the easiest and fastest way to get to the information that I need inside of a component to see what it really is. Just because something's called ABC doesn't mean it's ABC, it might be something else. You can look at a P viewer, but it might be misleading because a lot of the information, again, in the P is not correct. The date timestamp, for example, and some of the compilers will always reference out to June 19th, 1992, even though the product might have first been released in 2012. You can look at section headers. I mean, there's lots of things to do. You can basically do a little bit of forensics work. So for those people who like hacking, this becomes a nice, interesting, fun thing to look at. Just a dependency walker. So once you've identified the components, you want to know about the dependencies, and those also are critical. Identify all the DLLs that the program calls, because this way, just the component might not have a vulnerability, but the DLL might have a vulnerability. Pull in threads, if you will. Sample DLL depend screen. And if you look, here is a program called ECR, and inside ECR, these are all the routines that it calls. So, we can identify the component, but then we look at the vulnerability database, and it only gives you one component at a time. And if you've got 500 components, that's a painful process. That could be a good punishment for someone who has done something wrong. You wrote bad code, here, go and look at the components and figure out whether or not they have any vulnerabilities. An evil thought. And again, what about after installation? What if it's overwritten in the library? Kind of tough. So once you've done this, what you might want to do is look at creating a simple database. Here's the table that identifies the product, the name, the version, the older version, the copyright, trademark, date, whatever. Here's a list of the vendors for the components. And again, the component name, the version, the old version, the trademark, date, flag if you have any comments to make about it. Like, if you see this component in any of our products, it's bad, don't use it. And then you can have a table with the CVE so that you're not constantly having to go back. So once you've got a whole series of products installed and someone says, oh, there's a bug in OpenSSL 101E, you could actually go back and pull out a fast list and say, oh my gosh, we got to worry about it on these 4 machines or any machines that have this product installed. Interesting idea, right? So in the interest of saving time, the end goal is to create a program that looks at all the components by the products. So here I would have a product called PA version 4.0, and it did the extraction, tells me I've got JBoss, JRE, MySQL, PostgreSQL, and Tomcat in it. And then I can look up all the CVEs by the component. So here's JBoss, and here we have 5.1, but I've told it to pull up everything and here's a list of all the vulnerabilities. And you'll notice maybe we put a flag that says relevant. Not every vulnerability will be relevant. Just because it's a vulnerability doesn't mean it's achievable. If you do find a vulnerability, you might want to mitigate it. You know, so you would check off mitigation, and then if you had a comment to make, so for example, you have a mitigated vulnerability, but it's not relevant, you might just say it's not relevant because we don't allow something to happen. Something being like exploitation or access to that component. More importantly, the cool thing is, what if you could select the component and say, show me all the products that use that component. Show me all the vulnerabilities that are associated with that component. This is just a suggestion. This is actually fragile code. You will never see this in the marketplace or anything else, but it's an idea and a suggestion of how to handle this issue with what's in your software. So I know I talked kind of fast. I was told I had 30 minutes. I'm hoping I'm on time. Questions? Comments? So static and the question was, do we do static and dynamic testing on third-party software? And the answer is, you should. You should always do that sort of stuff. Sometimes creating the test harness becomes very difficult. Static code analysis on code that you don't own the source to is often very difficult. So you have to do a black box analysis. Try and feed stuff in to see if it complains. And if you validate inputs on most of the stuff, you handle most of the problems. Other questions?
This is like in general among the peers of your industry. Do you see that it's a standard practice that people have adopted static and dynamic testing for third-party software? So more of a question from the perspective of state of the industry.
So from a company perspective, if I bring software in, I have people who will do analysis. They'll do fuzz testing against it. They may not have access to the source code, so therefore they may not be able to do a full static analysis. There are some people out there that sell snake oil that say they can statically analyze the binary executables, but that's problematic. I've seen them claim it, and you know, sometimes it sort of kind of almost doesn't work right, usually. From a vendor point of view, yes, vendors usually will attempt to do the analysis, but the biggest thing they do is they do the input checking. So if I'm going to send something to a third-party piece of software, before I send it, I make sure that my bounds are correct and check it. Other questions? I'm sorry, hand over that way for a second.
I have one question regarding recent Bash Shellstorm and SSL. So how developers, software community can trust on the open source software? Is it like we can? Is there any certification body as such where they certify these are the open source components we can use?
No, I mean open source, it's great. Open source is great because lots of people work at it, you know, and every time someone talks to me about open source and security, I cringe because security professionals are too busy trying to defend against and protect against hackers to go and have free time to look at open source. So open source gets to work well and fast because that's the concentration. No one goes out and looks at the open source and says, did they implement the open source correctly? They just say, does the open source work? And that's usually the community at large.
Okay. But how do we solve this challenge of using open source?
How do you solve the problem of using open source? I don't know, I don't sell open source. You know, personally, open source, one would anticipate that someone who is knowledgeable in the area of computer security would actually review the technology. And the issue is that that doesn't happen as much as we would like it to. I don't see it ever happening. So I can't really tell you how to solve it. I can tell you that, hey, maybe a company could start up and do the review of the open source and then sell you open source code. No, it doesn't work like that. Not so sure.
Thank you.
Maybe a service that can be offered that you certify certain open source that they don't have so-and-so bugs or whatever.
The problem with a lot of these things is that even when you write the code and it's been certified, you can't anticipate the usage model. The question that I heard just before, when was this going on? The question I heard just before, which I thought was great, was what keeps you up at night? What keeps me up, besides cups of coffee, is usually the fact that the threat models of the usage models and the deployment models of the infrastructure that I'm in is constantly changing. And just because something doesn't have a vulnerability today doesn't mean that it won't have a vulnerability tomorrow when the usage model changes. So we're in a really dynamic environment. It's great and it's fantastic and it's very energetic. But a certification today doesn't guarantee that something will be valid tomorrow. Take FIPS 140. It's the Federal Information Processing Standard that validates cryptographic algorithms have been implemented properly. It works really well until you look at the digital signature standard with the blown random number generator. Here it is, it was validated. It was, hey, this is great, this is fantastic. And then they discovered that the algorithm they were using for the random number generator, which part of the validation, was bad. So anyone who tried to create a program that certified that software was trustworthy would only be able to certify it's trustworthy at a given instant. And there's no way they could possibly come up with all the permutations. You know, the best you can do is to constantly monitor to see, has someone found a new vulnerability in the software?
So one thing which you might do is like create a secure SDLC program within your organization and consider the open source code as a part of your SDLC program. So just like every time you're building your code, etc., you should ideally test it at various phases. Do the static